All right, second lesson in our exponents unit is going to be talking about negative exponents. I want to show you these examples before I tell you what to write in the blank. If we had x squared divided by x to the 7th, this is very similar to what we saw on the last lesson. If I expanded this out, I would have x squared as x times x to the 7th would look like this. Remember that x is a number, it's a constant. So let's say this is 2's everywhere. 2 divided by 2 would make 1, 2 divided by 2 would make 1. Well, what happens is I have nothing in the numerator, so I have to fill that spot with a 1 because these things are canceling to make 1. So I would make my fraction have a 1 on top and then figure out how many x's are getting multiplied on the bottom. 5. So you're doing your rule here where with quotients or dividing we subtracted the powers. So you're really keeping the base of x and then you're taking 2 minus 7. You always go top number minus bottom number if you're going to use a quotient rule like this. 2 minus 7 is actually negative 5. But they're never going to let you leave. I shouldn't say never, but most of the time they'll say put your answer in terms of positive exponents or positive powers. We can't leave it like this. But look at the similarities between getting this answer, and I'm saying, okay, we can't leave it like that, and then this answer that is okay. Well, they both are x to the 5th, but this one's negative, this one's positive. Well, it's almost like this is over 1, right? Any whole number you put over 1 to make it a fraction. So what if I were to sink this to the denominator and then have a 1 there, 1 over x to the 5th, kind of making it like a reciprocal, that kind of thing. Then these answers are the same. So that's exactly what we do. If you have a negative power, you take that base of the exponent with its power and drop it to the bottom and make it positive. So we're going to say we move negative exponents and make them positive. The whole point of moving them is so that they are no longer negative. So don't forget to change them into a positive power. See, it was negative, now it's positive. Okay, so let's try an example. If this is just x to the negative 3rd, they would not let us leave the answer this way. So since this has a negative power, I'm going to drop it to the denominator and now make it have a power of positive 3, and I would fill in the top with a 1. So this is equal really to 1 over x cubed. I wish I could sing or rap good because I always joke and say, okay, you know that Snoop Dogg song, which is really old, drop it like it's hot. If a negative's got an exponent, drop it like it's hot, drop it like it's hot. So whenever it's got a negative, you drop it to the bottom. But what's kind of neat is sometimes we might see negative exponents on the bottom. You can move it to the top. So it either goes to the bottom or goes to the top and it'll change its sign. All right, so let's try a set where it says to simplify the following expressions using only positive exponents. All right, on number 1, we kind of have a multi-step simplifying here. On the top, we've got multiplication and then division. Well, we need to do multiplication first because it's together on the top. So remember, our product rule says to add these powers. So it'd be x to the 5th divided by x to the 8th. So you got two options here. You can do what I taught you on the first lesson and just subtract them any way you want and then figure out where do they go. So I would see 8 minus 5 is 3, but the bigger number's on the bottom, so this would really equal 1 over x cubed. Or do your quotient rule where you keep your base of x, subtract top minus bottom power. That gets you x to the negative 3rd, but you can't leave it that way. You would have to sink it to the bottom, make the power positive, and then fill in a 1. So either way, you get the same answer. It's just your preference. All right, number 2. We got several options. Let's go ahead and say, okay, I'm going to stick to what I did on number 1, and I'm going to combine the two exponents on the bottom. So since we're multiplying, we're going to add the powers. Negative 3 plus negative 6, still negative 9. And then we have x to the 8th. Okay, you could do your quotient rule where you keep the base of 8. Remember, you got to subtract top minus bottom. That would be 8 minus, but then the second number is also a negative. When you have minus a negative, that turns into plus a positive, which would be x to the 17th. You may not like that. So what I would also maybe think is let's move this negative power to the top and make it x to the positive 9th times x to the 8th. And then you could do your product rule and add 9 plus 8 and get x to the 17th. Probably going to do that on some of these coming up. All right, to number 3. Again, I do want to show you this. This is important. Let's say I do want to stick to multiplying. So I'm going to add negative 8 plus 8, which is x to the 0, divided by x to the 4th. This is tricky. Do you know what anything to the 0 power is? It's not 0. Let's check. Let's say I have my base is 10 to the 0 power. It's 1. 5 to the 0 power. 1. 2 to the 0 power. 1. 1 to the 0 power. 1. Anything to the 0 power, this is actually a 1. So I get 1 over x to the 4th. And that does not have a negative power, so I'm good. Okay. Number 4, I think I'm going to start moving. So any part that has a negative power is going to move across this division line. So this goes down here, and now it's going to be a positive 4. This goes down here, positive 4, and these are all getting multiplied. This goes down here, and it's positive 8. Remember that exponents have to have the same base. So you can put the x to the 4th times x to the 4th together, and then the y to the 6th times y to the 8th together. So 4 plus 4 is x to the 8th. 6 plus 8 would be y to the 14th. Nothing was on top, so we fill that in with a 1. We've got 2 more. If you want to pause and try them on your own, you can. Number 5, I'm going to go ahead and move this x to the negative 2nd down to the bottom, and I'm going to move this x to the negative 3rd to the top. X cubed is staying where it's at, so I would have x cubed times an x cubed, this one moves, over x squared. X cubed times x cubed would be 3 plus 3 is x to the 6th divided by x squared, and then I'm just going to do 6 minus 2 would be x to the 4th. Then number 6, I'm going to move, move, move. Down here, up here. So what's actually on the top? Only this x to the 8th. This would be x cubed times y squared that was there times a y cubed. I'm going to put my y's together first. It doesn't matter. 8 minus 3 would be x to the 5th on the top, and then 2 plus 3 would be y to the 5th. You can't cancel these because they have different bases. This is x, which is most likely a different number than what y is, so you would leave it like that. Okay, and then the second part of this is write the following expressions without negative exponents and without parentheses. So if you look at this, 7, 8, and 9 are similar in that they don't have parentheses at all, whereas 10, 11, and 12 do. So the top 3 will go together, the bottom 3 will go together. On number 7, I need you to know that 2 is not to this power. 2 is really to the first power. It has nothing right after it. Only the x is to that negative 3rd power. It needs to be fixed, so it needs to sink to the bottom. Right now, this is like over a 1. 2 is fine to stay because it has a positive first power, but the x cubed would go on the bottom. And that's all they want you to do. Right, number 8, I'm trying to trick you. This negative in front is okay. We just can't have a negative power. Well, negative 5 is just to the first power. The x is the problem. So I would keep the negative 5 on top, sink the x squared to the bottom. Okay, pause and try number 9. Same thing, this negative 8 would stay on top because it has just power of 1, and then x to the negative first power would sink to the bottom. It'd be x to the positive first, but I don't need to write that. All right, and then the 3 with parentheses. This time, this whole thing is to this power. So I need to drop this whole thing to the denominator. So it'd be 3x to the positive first power. I would have to fill in the top with a 1. This to the first power is just itself, so I'm just going to say it's 1 over 3x. Number 11, this whole thing is to the negative second power. So I'm going to drop that down, keep it in parentheses. Now it's to the positive second power, fill in the top with a 1. This is our power rule, where I would say, okay, it's 5x times another 5x. 5 times 5 is 25. X times x is x squared. But remember our rule, we square, or we take the coefficient to the power. 5 squared is 25, not 10. And then x squared is x squared. Keep the 1 on top, so we get 1 over 25x squared. All right, you can pause and try number 12. This whole thing is to a negative power. So I'd put 1 on top and sink the negative 4x quantity cubed, make it positive. You want to think negative 4 to the third power. That would be a negative since the power is an odd number of negatives. So it would be negative 4 times 4 is 16 times 4 is 64. And then be x cubed. So this got the power and this got the power. You could float the negative up or leave it down with the 64. It doesn't matter to me. And that's negative exponents.